Continuing 6.5, we're now on the factor theorem. And the factor theorem states that f of x has a factor x minus k, then f of x equals 0. This means that if we say that negative 3 is x, what we're plugging in, that means that we can use it in synthetic division. So, solve using synthetic division to factor the following when you have f equals, or f of negative 3 equals 0. So what that means is, once again, we double check. We're going down in order. X to the third, x squared, x, and no x. So we have all of them. We don't need to put zeros in. And it's 2x cubed, 11x squared, 18x, and a 9. And the negative 3 goes on the outside. So I drop down the 2. 2 times negative 3 is negative 6. 11 plus negative 6 is 5. 5 times negative 3 is negative 15. I add those together to get a 3. 3 times negative 3 is negative 9. I add those together to get 0. Good. This is one less, right? So if this is x cubed, that is squared. So that's 2x squared, 5x, 3. Okay, no problem. But we have to work at this backwards. I'm saying that it's negative 3, so what gave me that negative 3? What equation gave me that negative 3? Well, looking backwards, this is the equation, right? If I subtract 3 on both sides, I get x equals negative 3. So I got to think of this backwards. The equation that would give me that negative 3 is x plus 3, which is why I have this x plus 3 out in front and this in the back. So what I need to do is, the problem wants me to factor as far as I can. So when we're looking at this right here, this method, I have to see if I can factor this, and actually you can. You can either do slide and divide, which means I slide that 2 over, so I get x squared plus 5x plus 6, and I try to factor it that way and divide by 2. Or we can use the method that we just talked about in the last section, which was factoring by grouping. If I wanted to, I could split this 5x, right? I could split that 5x into something. All right, so we slide to get a 6 and a 5. So we figure out that that is 2 and 3 using slide and divide, I guess. So with slide and divide, that's telling me that what multiplies to give me 6, that adds to give me 5. Well, that's 2 and 3. So I'm splitting that 5x into 2 and 3. That's where I'm getting the 2x and the 3x from. When I multiply those two, I figure out what adds to do that. So that's how I'm splitting up into my two groups. So instead of using slide and divide, I don't need to divide at the end. I actually slid 2 times 3 to figure out what my two different things would be, a 2 and a 3. That helps when you split things up to factor by grouping. So now that I have a 2x squared and a 2x, I can group those together. Both of these items have an x and a 2 in common, so I take out a 2x. This has a 3 in common, and if you notice, when I pull those both out, this is a 2x and a 3, so I combine those together to get 2x plus 3, and I drop down the x plus 1. So my official final answer is what I just factored, plus you can't forget that x plus 3 that I had in the beginning. So all three of those together are the factors, which would make it much easier to solve for. Once again, let's try to factor this. It's saying that x equals 2, so I check to make sure I have all the exponents down the line, which I do. A 1, a negative 2, a negative 9, and an 18. I put the 2 out here in front, so I drop a 1 down. 1 times 2 is 2. I add to get 0. 0 times 2 is negative 0. Sorry, it's 0. Negative 9 plus 0 is negative 9. Negative 9 times 2 is negative 18, which gives me another 0. So I go 1 down, and this is x cubed. That makes this x squared. So that's x squared plus 0x minus 9. So if there is no x, I could just write it as x squared minus 9. Once again, if my answer is 2, I need to look backwards. So if it's a positive 2 is my answer, then the equation was x minus 2. So there's the equation that I would have used to start. And now I have this equation. So can I take x squared minus 9 and factor it? Well, yeah, I can remember my difference of squares that we talked about. And this is an x squared minus 9. This term is squared, so when I square this term, this becomes 3 squared. So it's x minus 3 and x plus 3. And I also have this x minus 2 from before that I can bring down. So there are my factors for the problem. In example 5, it says, you are an accountant for a manufacturer of radios. The demand function for the radio is this. So there's my function. Where X is the number of radios produced in millions. It costs the company $15 to make a radio. Write an equation giving profit as a function of the number of radios produced. Well, this is the price charged per unit. That's what it's saying. So that's the formula for the price per unit. And the number of units is X. Okay, so they're saying that the cost is 15. So when I go to set this up, what we're basically saying is, so the profit right here, the equation for profit is the price charged per unit, which is 40 minus 4x squared, times x, which is the number of units. And then we have to take away minus the cost per unit. So this is what we're charging, right? We're charging this equation per each item. So that's why it's times. So it's this, which is the cost, times x, which is how many, minus the price we're charging, 15, for how many. So that's where our equation comes from. So I need to take that x and distribute it through. All right, the revenue and the cost. I need to take that x and distribute it through. So I get 40x minus 4x cubed, and I have a minus 15x. So when I combine my like terms there, I get negative 4x cubed plus 25x, which what I can do is, I guess that's all we wanted for that one. So the company currently produces 1.5 million radios and makes a profit of 24 million. But you would like to scale back production. What lesser number of radios could the company produce to yield the same profit? So basically, that's our profit now. That's what our profit's going to be. It's saying that we have 24 million. That is profit. So we're going to assume that this is in millions. So instead of me writing down 24 million afterwards, we're assuming that x is in millions. So, and I go to solve this, I move that over there, and it says that we have 1.5 million that is produced, so that's basically stating x is 1.5. So if I subtract, there's my equation, x minus 1.5. So the point that we're getting at is, I have my x, which is negative 4, x squared, which I don't have, and I have my x, which is 25, and negative 24. And I know that this is 1.5 out in front. So down here, I bring down the negative 4. Negative 4 times 1.5 is negative 6. I add them to get negative 6. Negative 6 times 1.5 is negative 9. I add those to get 16. 16 times 1.5 is 24. I add them to get 0. This is x cubed, so that is negative 4x squared minus 6x plus 16. And the reason why I did that, up above here, x minus 1.5 is, that is what the other factor is of it, x minus 15. So I look at this to see if for some reason I can factor or take anything out, and it looks like I can take a negative 2 out of every single item, which is why the negative 2 out in front. And that I can use the quad to solve. And basically what I find out is I end up getting 1.39 for x. Well, if 1.39, when I use the quadratic formula to solve it, we get 1.39, that's actually saying I have 1,390,000. And up above, I also know that is 1.5. So there's your homework. Try your best to use both the synthetic division and try to use the long division method for factoring. And we will see what we come up with from there. If you have any questions, please feel free to email me at any time.